complex numbers.
Okay, welcome to another class of King Solomon and David Picosi on algebra. Now, today we'll be dealing with complex numbers, algebra complex numbers. So what is a complex number? Now, it is very simple. Complex number is a number that has the summation of a real term and an imaginary term. But one thing is that complex numbers actually arose from certain quadratic functions. So in as much as people brought mathematicians were able to bring some solutions to quadratic functions, and they realized that there are some of the quadratic functions, they find it difficult to solve it, and at the end of the answer, they are finding some of the answers in negatives and a root. That's the root of a negative number, like maybe negative a. So when you are done solving some of the questions, you will get maybe 2 plus or minus root of negative a and the root and other stuff. So now when they are done solving such examples and they find this and that, they realize that if they are supposed to use the normal methods of solving the quadratic equation, it wouldn't work. So they have to go in for a lot of method of completing squares, the almighty formula we all know to solve such examples. So out of this was when we got complex numbers, that if you write something in this nature, then there is a real aspect of this particular solution root, and there is an imaginary aspect of this particular solution root. For example, if you have a quadratic function like z square, minus 4z plus 5. Okay, if you have a quadratic function like this, you realize that because of the polynomial term here, which is 2, or the polynomial degree here, this quadratic function will have only 2 solutions. This quadratic function will have only 2 solutions, and the solutions it will have here is z1, let's say z1, and z2. So if the solutions it will have here is z1, z2, then we can say z minus z1 multiplying z minus z2 is equal to 0. So now if you are supposed to break this particular solution down, you'll be getting something like this, assuming the z1 and the z2 are each solution. Now to solve this, you have to apply the familiar formula you all know as the almighty formula. And what does the almighty formula say? The almighty formula says that with this, if you want to find our z1 and 2, then the almighty formula is the minus b plus or minus root of b squared minus 4ac all on what? 2a. Root of b squared minus 4ac all of 2a. So if you want to put it in it and we solve for this particular equation, then to find our roots z1 and z2, what are we getting? We'll be getting minus 4 plus or minus into bracket minus 4 all squared minus 4 into bracket 1 times 5, because here is ax squared plus bx plus c. So in this nature, so here we can assume that here's the az squared plus bz plus c. Okay, so that means our a is 1, our b is negative 4, our c is 5, and divided by 2 times 1. Okay, so now when you do this, you are getting 2 plus or minus root of negative 4 on 2. So 2 plus or minus, so this is a 2 minus this is the formula. So 2 plus or minus root of negative 4 on 2. Okay, so now this is what we are getting. So if you get this value you got here, that is the 2 plus or minus root of negative 4 on 2 are in 2 things. Now what are the things of this number here? The 2 you see is the real thing, or the real part of this particular solution. And the negative 4, the root of the negative 4 we see here, will become the imaginary part of this particular solution. So now what is a complex number? Complex number has a conventional sign or a conventional representation, and the conventional representation of complex number is z, normally represented by the letter z. So therefore complex number is simply the summation of a real part. So if you have a real part and an imaginary part, so anytime you sum a real part and an imaginary part together, you get what we call a complex number. So now the real part is also represented by this REZ plus an imaginary part, which is IMZ. And it will give you a complex number. So now from here, complex number is simply, so the real part is, you can say x plus IY. X plus IY. Now if you want to write this in its compacted form on the component notation, then we can say the complex number z is equal to x, y. The complex number z is equal to x, y. Okay, now the I we see here that makes this whole thing a complex number is because I is always equal to root of -1. So anytime you see root of -1, it is I. That is at the imaginary part. So from here, the x here is the real part, and this part is the imaginary part because of the I. When we look in other books or other studies, the I is sometimes also represented by J. So now, in applied electricity, there's a way we can use complex number to find some power in other circuits. And you realize that in that case, they'll be using J because I is already represented over there as current. Okay, so now if this is the case, let's come back to this particular question. What can we see over here? We can see that we have 2 plus root of -4 on 2. Now -4 here, root of -4 is simply root of 1 times 4. So now root of 1 times root of 4. Root of 4 is always 2. So therefore we can say root of 1 is I times 2. So which will give what? 2I. So if you want to write this particular solution here in a complex form, then we will get 2 plus or minus this -4 will give us what? 2I, which will give us 2I on 2. So these two can take these two away, and finally we'll get 2 plus or minus I. Okay, so getting the 2 plus or minus I, this 2 plus or minus I will have 2 as the real part and I as the imaginary part. Okay. Let's look at something also very here, which is also very important. Now, when you consider the compacted form, which is the z equal to x, y. So in writing the compacted form, you don't bring the I part of the imaginary part. We don't bring that. So now when you consider this compacted form, what you can see here is that with the compacted form, it is always derived from what we call the Eigen diagram. So the compacted form is always gotten from a diagram we call the Eigen diagram. So it is a plot we call the Eigen diagram. Like for instance, if you have our normal Cartesian XY plane, our normal Cartesian XY plane, every point on it will have some values, maybe x1, y1. I get it. And this is found on the Cartesian plane. But for complex numbers, they are drawn on the Eigen plane, not the Cartesian plane. So there's something we call the Eigen diagram. And this is how the Eigen diagram is. It also has pi, there is pi here, there is pi here, there is pi on 2 here, this side is a negative pi, and this side is a negative pi on 2. So this side draws the diagram, the Eigen diagram, and here is assumed as first quadrant, our second quadrant, our third quadrant, and our fourth quadrant. Okay, so without wasting my time, let's quickly move to the addition and subtraction of a complex number. So if you have two complex numbers, how do we add and subtract them? Okay, so if you have a complex number, how do we add and subtract complex numbers? So let's say you have z1, which is x1 plus y1, and you have z2, which is x1 plus y2. And we are asked that A, let's find z1 plus z2, and B, you have to find z1 minus z2. What we do here is that in complex numbers, if you want to add complex numbers, because if you have a complex number z, it has two parts, which is the real part and the imaginary part. Anytime we want to add two complex numbers, we add the real part first separately, and we come and add the imaginary part separately. So here we add both of them separately. So here z1 plus z2, we add their real parts, so these are their real parts. So therefore, this is x2, y2. So we get x1 plus x2, all plus, and we come and add their imaginary part, which is y1 plus y2 I. Okay. Now, if you want to subtract the complex numbers too, you also do the same thing here. So x1 minus the x2 plus minus the y1 minus the y2. So now this is how we subtract the the complex numbers. So x1 minus y2, x2 minus y1 minus y2, or I. Okay. Now if you understand this, let's take one example. But you should also understand that, note something here, that the addition of complex numbers, is itself commutative and associative. So you already know the commutative property and the associative property from the normal theory. So what we are trying to say is that if you have a complex number here plus another complex number is the same as what? Z2 plus what? Z1. So this is what? Commutative. This is commutative. If you have also to Z1 3 10 plus Z2 Z3. Okay, if you have something like this, then it's the same as Z1 plus Z2 into bracket plus Z3, and this is what? Associative. So addition of complex number is itself commutative and what? Associative. Now let's take one or two examples under the addition and subtraction of complex numbers. Okay. Now you have, so example, add the following: Z1, which is equal to 1 plus 2i, Z2, which is equal to 3 minus 4i, and Z3, which is equal to minus 2 plus I. Okay, so we have these three complex numbers, and we are asked to add them. So what you do is that you have to add the imaginary part. So adding the imaginary part, so Z1 plus Z2 plus Z3 is equal to, you have to add the imaginary part. So adding the real part first. You have 1 plus 3 minus 2. So 1 plus 3 minus 2 will give us 1. Okay, so will give us 2. This is the real part. So now, finding the imaginary part. Okay, that one will give us 2 minus 4 plus 1 I. Okay, so 2 minus 4 is minus 2 plus 1. That gives us minus 1 I. So minus 1 I is the same as what? Minus I. So therefore, Z1 plus Z2 plus Z3 is equal to the real part plus this part. So we have 2 plus negative I, which is the same as 2 minus I. 2 minus I. Okay, so thank you very much, and I want you to get some examples and solve it. So the same example, you can subtract z1 minus z2 minus z. Okay, so if you want to do the subtract z1 from z2 from z3, okay, let's take maybe z1 minus z2 from this same question. Then what you do is that the x part, you subtract the x part, the real part, so you get 1 minus 3. So this is z1 and z2, 1 minus 3, which will give us minus 2. And we get the imaginary part, which is 2 minus 4 I. So 2 minus 4 will give 2 plus 4, which is I, which is equal to 6I. So therefore, z1 minus z2 will then give you what? Minus 2 plus 6I. Thank you for joining this video, and let's meet in the other video. Thank you.